Hello! In this robotics training session, we want to go to servo motors and teach you how to control and work with servo motors, which are widely used in robotics, which will be a very interesting training. Because with the help of servo motors, you can build powerful and functional robots that can even be used as assistants. And since we will build such robots in this course, it is necessary to be well acquainted with all the parts used in building robots and learn how to use these parts. So let's see what a servo motor is and how to use it. First, it is better to know that a servo motor is also a type of DC, electric motor, whose purpose is to use feedback control. The inertia force in servo motors is very low, which is why these motors are fast, meaning that they can achieve high torque in a wide range of applications. We must use PWM waves to control the speed and direction of the servo motor. That's why we have been talking a lot about PWMs in the past sessions, and we are teaching various methods of using and creating PWM. Well, if you have watched the previous sessions, you know that PWM is a type of square wave whose duty cycle we can control very well, which results in good control over the speed of the motors. Servo motors have the ability to be positioned at a specific angle depending on our needs. What does that mean? For example, we want a robot arm to move a degree from its place. In this case, by giving the appropriate signal, we can position the motor in the desired direction by a degree, and even how it moves when it is moving towards the angle of a degree. We can control it, meaning we tell it at the same time what degree it should be at and how fast it should move towards that degree. I need to learn more. I will do all these things in the next session, and we will put everything into practice after its explanation. So you see a type of servo motor here, whose internal structure is also characteristic, and they explain it in more detail. One of the good features of servo motors is that they have gearboxes, and as you can see here, it is quite obvious. Now, depending on the type of servo motor, some of these servo motors have gearboxes inside the packaging, which is actually the mold and frame, and only the rod we want to use comes out, or the screwdriver we want to use. Some, like the model you see, have a boxing grip and the screwdriver outside. Sometimes this depends on the model, because there are many models of servo motors. The main part that actually makes servo motors different from other DC motors, even though their main motors are DC motors, is the main part. This is because, first of all, there is a control unit that is electronically controlled, and here you can see a picture of it. In fact, this is the part that controls the engine. It controls the DC and can rotate the motor with a high speed. And when we send our commands to the servo motor, that is, when we send the PWM to the servo, in fact, that command comes first and reaches this circuit, and this circuit interprets and analyzes that command. What does it do? It executes the movement on the motor. In fact, you could say that this part is the control unit and microcontroller for the servo motor. So here you have seen a simple structure of a servo motor, which of course is the basic and main structure of a servo motor. And in the servo motor, there is also a part that has a pulley attached to it, and it is usually called a position detection potentiometer, which is also written here. If you look closely, there is a pulley on top that. This shaft or rotation arm is also connected to it. In fact, it is the same unit that comes with this unit. That is, this microcontroller comes with it based on. This module located here detects how many degrees this shaft or this arm has rotated. Or for example, the sound is rotated 80 degrees. The sound is rotated 80 degrees, or what position it is currently in. It detects these based on this potentiometer here, meaning that this microcontroller that you see here makes all these detections and then comes and makes the appropriate decisions. So what is being discussed here, and many people may have a question about, is why do we need to use servo motors in robotics? If we want to explain it, one of the reasons is that the servo motor is moving for a long time, and just as it can accurately detect the angle and position of the movement angle, it can control the angle of movement in the servo motor, which is very important and even vital in the tradition of robotics. Also, because the servo motor has a box gear, this has made it very powerful, which allows us to build powerful robots that can, for example, pick up and lift heavy objects. Or if it is going to catch something, the finger receiver section should have good power. All of this is possible with servo motors. The servo also works in this way that when a signal is given to the servo, it must be recorded from the feedback system it has. The exact position of the motor movement is determined. So the motor circuit, along with the microcontroller, can accurately identify the speed and position of the motor movement. and it has very accurate and high precision control over the motor move. Well, I think up to this point, you have known the servo motor well, and I tried to explain the structure and main base of the servo motor to you very briefly and without exaggeration. As a final explanation, after which we are going to get into practical work with the servo, you should know that there are many servo motors in different models and with different working voltages that you can. Based on the project you want to use the servo motor for, choose the right type, but their basic operation is the same as explained here. And in future sessions, you will learn how to control it. In the introductory robotics training series that we are now at your service, the servo and motor that we will use are as you see them. And in fact, the general shape is like this. As you can see, it's pins, and in fact, the gearbox are inside the package, and there is nothing else outside except this. In fact, a small rotor that allows us to make our connections to it. And this has made it very easy for us to use this servo. The name of this model is SG No Watt, which is easily available in the market, and you can easily obtain it. It is very small in size, and we are going to work with this servo motor and build our own arm robot. In the previous session, I had said that we are going to use this servo that has a set of wires, and I also explained the color of the wires to you, but I will also put it here. I will point out that here you see that we have the red and orange coffee. So the coffee is GND, which means it is connected to GND, or the same 0 volt or red ground, which you know well that the voltage is positive, and the orange wire is also the wire that we give the signal to the servo motor. That is, we give the same PW signal from this wire to the servo. But you will get to know it more, and first we will go to the Protoss to do the work, and in fact, let's implement the servo motor in the Parados using a circuit. A PWM generator based on PONST and P5 and using a microcontroller. You will see how the circuit should be connected to the servo, and then, if possible, in this session, if not in the next session, we will implement its physical circuit so that you can see completely how we can control it. And for the microcontroller, as usual, you will use Arduinos. So let's go to the prototype to see how to build a control circuit for a servo motor. As you can see and as mentioned, here in Protoss, I implemented a circuit that is based on both the 5555 IC and the microcontroller I used is the 328th atom because later on, when we want to move on to Arduino, we want to use the Arduino Nano, and my Arduino Nano microcontroller is also the 328th atom. Here, as we can see, I closed the circuit so that the video wouldn't take up too much time. You saw this method of closing the circuit in the previous session, and I taught you. Here, as you can see, we have a PW generator circuit based on PONS and 5, which you were familiar with, and I have placed a servo motor here, which you can also see. In order for you to have this servo motor and these accessories, your ProUse book needs to be up to date, so I'll include this book with the mites. I have provided this tutorial for you, which you can access from the link I provided at the bottom of the video description section, and download these files and libraries, meaning all the files related to this session. I put the macro for each session. So here, as you can see, I put a servo motor, which is our servo motor, and as you can see, it has its own wire, which is control, which means control. There is a wire to which we give the PWM pulse, VCC, which is a voltage of 5 volts, and a pin that is a pin. As you can see, I connected the pin to the pin section of the circuit. VCC is connected directly to our 5V voltage. And if I right-click here, you'll see that I set the 5V. And then the control section is connected to the oscilloscope, so that you can see it is also connected to the microcontroller, but I will disconnect it from the microcontroller and connect it directly to the IC, PONS and 5, so that you can see how it can be controlled, which is also connected to the oscilloscope here, so that you can see its wave. Now when I come to do this simulation, which means that I click on this button, you can see that here the motor starts to rotate, and it will go to an angle of 180 degrees and stop because the type of PW wave that is being created, and you can also see in the oscilloscope, it only rotates the motor in one direction, and we did not give it the return command. That is why you see that it rotates so much and remains. I will hold the clock together again and start it from the beginning. See here is the PW wave. So it rotated 80 degrees on the sound and stopped. Now if we use microcontrollers and actually control devices, we can easily do something to rotate the servo motor in 2 different directions. And I'm going to do this too. We're going to rotate it in 2 different directions, and then we can even control its speed. And I'm going to implement the same thing in the Protoss, see the circuit again, and after we implement it on the Protoss, we're going to implement the same circuit physically, which means we're going to build it so you can see it completely and see it. The motor I put here is the same SJ note that you're going to use. And here I'm going to show you its image again. So this is actually the same PW wave that the IC is producing, and you can see it here. Now, if I were to cut the IC and cut the 5 and 5, I would have to use a microcontroller, right? The microcontroller also needs a magnet, which I have included in this tutorial for you. It is a magnet that, when it enters the micro and is poured onto the micro, creates a PWM wave for us. It is exactly the same wave that the IC is producing and is 5 and 5. So I come here. This time I connect the microcontroller to the motor controller base, which is again connected to the oscilloscope, and then I run the simulation again. When I run the simulation, as you can see, the motor is rotating slowly again, and you can see its PWM wave here. See, it turned 18 degrees and remained there. And just like that, you can create and close a circuit that allows you to control the servo motor. In fact, the PWM wave that reaches the servo motor allows us to control the servo motor accurately and correctly. Now we will continue with this circuit and make some changes so that we can change the direction of the servo motor. Let's change, and in order for us to be able to change the direction of the servo motor with the least possible parts and to make it cheaper, we don't need the 555 circuit anymore, and we will just use the microcontroller. So, what I'm going to do is I'm going to cut off all the connections related to the IC, which are 557 and 555. And the only part that I'm going to leave is the power supply part, which is the servo and the motor itself, our otoscope, and our microcontroller. This time I'm going to put the microcontroller in the middle here, and it's ready to use. Now, in microcontrollers, usually we connect the VCC and ERFA pins together, which means we connect them together too. The voltage of 5 volts or the positive voltage of our circuit. And now our circuit is almost ready. Now what we need to do is write the code for the circuit that will allow us to actually do what we need to do. We can turn this motor in different directions, and this time we want to add a push button. That is a button to control the speed of the motor and the speed of the servo motor. We also want to add 2 more buttons to control the directions. That is 1 button in one direction and 1 button in the other direction. So we want to do this again to see how it looks. We don't need the parts that were rejected by the IC, 5 and 5. That is, we calculated from here. We need the 328th and 28th atoms. The servo motor should stay. So I'll delete this one too. The potentiometer remains, and we are holding the position together now. So let's go to the parts, and here I will write the phrase push so that the push itself will come up. The inner push and its active type must be selected. Make sure that it says active in front of it. We double click to add it to this section. And then the potentiometer that we had, this is one thing we need here. If we want to use this push button, it will have such a shape that we can actually use this push button, for example, with the same key, which is what we will do. So as you can see here, I took that IC, the 37588 IC, and replaced it with Arduino and Uno, because using Arduino, well, to start with, you are. Just at the beginning, it makes working a lot easier and simpler, but look at the IC. The IC that we are using is a Mega 37588. That is, the same IC that we just placed, this IC is mounted on the Arduino and Uno, so that we can easily program it and use it. And this is the reason why I use the Arduino and Uno. So here you see our same servo motor, and what are the black, red, and orange wires that I told you about? Here I also placed the push buttons, and you can see that you can connect them to any pin now, but here I connected them to the analog pins, that is analog. I put this line for this push button, and the positive sign means that it rotates in the other direction. In fact, this positive is negative for the directions. Now I have a convention for myself. For example, if it turns to the right, it becomes positive, and if it turns to the left, it becomes negative. And so this push button rotates to the left, and this push button rotates to the right, and this push button that I put here, S, means face. With each push of this push button, I can increase or decrease the speed of this servo motor. Well, this circuit has another component, which is actually an LCD, which shows us the speed and angle of rotation of the motor on the LCD. But since I didn't have the action book for the Protoss, I didn't connect the LCD anymore, but I'll tell you which pins it's on so you can easily do it. Let's connect the LCD to the physical circuit, which of course we will connect to the physical circuit that we want to implement later, or we want to physically implement this circuit. We'll also see the status of the motor there because our circuit was supposed to be connected to a display, so the LCD is connected to pin A. That means the 4 and 5 bases are connected, and I will show you how to connect them. But again, look here, we have a steel and a steel. These two are important. Now, these initials are not important. What are we going to do? We're going to connect this SDA and SDA to exactly the same pins on the LCD. Next, I want to show you what module we're using for the LCD so you can see it better. So, I'll bring the LCD here. The LCD that we want to use is this, a character LCD, which you can easily find in the market and is also cheaper. As you can see, this LCD has a large number of pins, and if we were to connect Arduino directly to these pins, many pins would be wasted from Arduino itself. So what do? Let's use the A2C protocol so that we can only use 2 pins in the Arduino and send the image to the LCD. If we want to use this LCD, in addition to connecting the pins to the Arduino, what do we need to do? Connect its voltages and other pins correctly, which we see takes a lot of wires. But fortunately, a module has been made for LCDs, which you can see here. This module looks like this, and in this screenshot, see here. In this way, it mounts on the LCD, and we can now do all this wiring and connect all these pins to the Arduino or microcontroller. I only have 4 pins, 2 of which are negative and positive for the LCD's working voltage, which is 5 volts. We connect 5 volts to this module. And although the image quality is not good, here you can see STA and STL, which are our 2 data pins, which we send data to the LCD through this. So this module makes our work very easy, and we can connect our Arduinos to the LCD simply and with minimal wiring, which means that the cable was shortened to 4 wires. So now, as mentioned, we have implemented the module as we see it, and here we have put 12 volts for the servo motor, which is connected to its positive leg. The GND leg is also connected to ground, and the data or control leg, which is hidden and controlled, is connected to the Arduino pin, which you see here so that I can actually control it. One very important thing is to pay attention to the names of the other Arduino pins. So you will see a sine wave mode on the output. So here, as you can see, since the type of signal we want to send to the controller is PWM, you need to use the Arduino pins in your programming to control the controller that has this symbol in front of it. What does this mean? It means that these pins are analog output pins and have the ability to output analog waves or waves such as square waves that are specific to PWM. Easily output, and we can use it to control various motors or other systems. If you want to use pins that do not have this symbol and do not have PWM output, it is still possible. And finally, you have to use an analog to digital or digital to analog conversion circuit, which makes our circuit more complicated, but we want it to be simpler, so we can directly connect it to the Arduino itself. The circuit is programmed to run, so you must use these PWM pins. After we have made the connections like this, what are we going to do? Here we go with the Arduino coding. Along with this session, I have provided you with some files that you can see here. One of them is the full library prototype, which is actually a library. Protos is the tool that provides you with these tools. One is the schematic that I drew here, which I put in the Protos package for you. Another is a microcontroller for. A few minutes ago, I put the code that we were doing without this Arduino here for you to use. There is also the code that is the Arduino itself, which we're going to work on here and now, which I have provided to you. Well, I'll open the Arduino. So here the Arduino code was opened, and as you can see, they imported an LCD library. In fact, in the I2C mode that you see here, they imported a servo.h library for the servo motor. And here I have defined the LCD pins, and you can see that I have defined the pins ISF, I1 and I2 as inputs here. If I show this, you can see that the pins ISF, I1 and I2 are exactly the inputs. That is, when we press the buttons and each of these pins is tripped, an action happens in the code. Which you can see here that one side of the button is connected to GND and the other side is connected to Arduino. Now, whether it is connected to GND or to VCC, your definition is in the coding. Since I am providing the codes to you, you can easily change the structure. So what do we do next? As we can see, I have defined the pins as inputs so that it can actually control our motor, and we can easily view the code. Now, since I was discussing coding, please write the code yourself. I want to take my time. Here, I will only explain the main part of the code, and you can easily have this code with this tutorial, but because we write these codes professionally, and they are only for these tutorials. Some of the codes like the one you see on the channel can be purchased for you, my dears, for a very small amount, which we have put on the channel. I have put the link to this code at the bottom of the description section of this video. What you can easily do is enter the link and get this code for a very small amount and all the files that are related to this session and use this code easily. Now let's run the code and see how it works. What do we do to run the code? In order to actually program these Arduinos, you come here in the sketch section. You select the binary compile, which is possible with the shortcut keys of the Alto control. When you put this in the folder of this code, in fact, the file gives you a hex file. What you should do with that hex file is program it in Arduino. Then you right-click on Arduino and click Edit Properties, and from here, click on the program file on the folder, and the file that I told you to use during the safe mode is this. You see it is in hex mode. Pay attention to the font. Make sure to click the word bootloader because it gives several files, one of which has the name of the bootloader and one of which does not have the name of the bootloader, which you must use with the bootloader so that it is compatible with Arduino. I select this, that is, I select the tab method and click OK. In this way, that code, and that is actually the program that is programmed in my Arduino. Now what do? Here, I click on Run and run the program, and when the program runs, you will see that the motor is in the static state, but it is active, which means I have not given it permission yet. Now if I press and hold this button, you will see that the motor is rotating to the right at a very slow speed. Now if I press the minus button, which is the button connected to the 1, I hold it and you will see that it is rotating to the left at a slow speed. Now I want it to rotate a little bit more slowly. I will click this button a few times like this. In fact, when we connect the LCD, you will see why we increase the speed, and you will see it clearly in the physical circuit. So how many times did I press this button to increase the speed? Now if I press it, you will see that it is rotating a little bit more slowly. You can see that it is rotating more slowly. I will press the button again a few times like this. I will press this button 3, 4, 5 times. Again, you will see that this time the speed has increased again. As you can see here, the degree of rotation is how many degrees of rotation it is. I can rotate it up to 180 degrees. Look, I held this key down, so it turned 10 degrees this way and 10 degrees this way. Now I'm turning it to the left, and I'm pressing the key again. Now this key increases the speed to some extent. I press it again. It goes down again. See, this time the speed has slowed down again. Now I'm pressing it again a few times to increase the speed, very easily. With the program I just made, I can rotate a servo motor in 2 different directions and choose the speed of its rotation. And this is the first circuit. In order to get ready, let's slowly move on to making our first robots. We can make robots that move or have arms, for example, or something that can lift. And now we're entering the phase that our first circuit was for. So here we have the reset pin. If you connect this reset pin to ground and put a pin on it, every time you press that button, everything will be reset. See, because here we show a number. We want this situation to be reset. You can put a reset button, or you cannot put it and reset the Arduino itself. Well, for this task, it is better to get Arduino and Uno, which are not very expensive now, and do these things easily. The servo motor, which I suggest you change, is a Sechi note, as mentioned, and you can see its picture here again. You can see that the servo motor is still cheap. And you can easily have the first tools needed for the robot by simulating these parts, because in the next sessions, when we want to build the robot, you can have the tools. Well, having observed this, now we're going to physically implement this circuit to see how it works in the real and physical world. As you can see, my Arduino is connected to the computer here with USB, and now I want to go into the Arduino software and upload the code into this Arduino. What I do is that here I first enter the Arduino master and open the same code that you see here. Then I enter the Arduino and select my port, which is here. It asks me what the port is. Here I type the word Uno because my Arduino is Uno. And then I select Uno and click OK. After I do this, I click on Verify once to check my code to make sure there are no errors. And if there are no errors, it will click Done Compile here, which you can see. And after you click Done Compile, this time you click on Upload. And when you click on Upload, it will check the code once. If your Arduino gives an error and you see that, for example, you encountered an error while uploading the code, then this is because there may have been a code in it before. For this, you can go to the example section here. And for example, we go to the basics section and select B-Link. That is, we will do this later and select B-Link to put a sample code for flashing the LED in it that is different from the code that was in it before. So here, Arduino and Uno are selected, and this is a trick I will teach you. You will upload. If you encounter an error again, in any way, the way is to disconnect the Arduino once and connect it again to the computer and reconfigure the port, and then click on the upload button. So here, as we can see, the upload starts and the Arduino light is blinking, and here it shows us the upload progress, which we have seen. This means that the codes have been successfully uploaded to the Arduino, and now it is ready to use, and we are going to turn on the servo motor. And let's connect the rest of the example to the Arduino and see how we can control the servo motor in the real world. So as you can see here, I have assembled the same circuit that I presented and worked on the Protoss so far, and it is exactly the same schematic that I explained to you. The motor that you see here is an SG Note servo motor that you can see well and you can easily guess, which is connected to the power supply, and the PWM wire, which is the same orange wire, is connected to the Arduino pin, and the rest of the connections are the same. Because now, when the video is not taken, and this video is also very long, I assembled a circuit, and you can also see the LCD character that I was talking about here, and with the module that I explained to you. So I will put the LCD here, and this is the set of keys that are supposed to work, which is here to determine the speed. This key rotates to the left, and this key rotates to the right. All of them are connected to the Arduino. So I turn on the power supply, which is on 5 volts. When it turns on, you see that the motor is on 90 degrees on the LCD, which means that you can actually set it to any mode. The last time it was set to the same mode. But the white part automatically switches to normal, which of course you can change all this by writing code, but the code that we have provided to you works like this. So here you see this. Now if I want to change the speed from normal, I press this same speed change button on my wand once. It becomes high. You see that it means high speed. The lowest is low, which is very low. Normal is medium. And high is high speed, which means if it is high and we press these left and right keys, the motor will rotate at a faster speed. But if it is on low, it will rotate at a much slower speed. Well, this is our motor, which I've wrapped in plastic here, which is actually the servo motor itself. And I'm going to put the plug on it and put the key on the left. And look at the motor. You can see that I held the key and the motor started to turn. And when it reaches the end, it stops, and here it shows us the number. The number is 0. And again, if I want to turn it in the opposite direction, I'll hold the key this way, and this time, you'll see the number change. This number here actually shows the angle of rotation of the motor. Look closely, see the number. For example, I want to bring it to 90 degrees. I'm holding it, I'm turning it, and now it's even gone. I'll go back with this one again. The whole thing is now 90 degrees. The whole thing is up. Now I want to go 18 degrees. I'm holding it. You can see the motor is turning. And they reach the 8 degrees sound, which is the last state of the engine. When the engine reaches the end of its angle, even if you hold the key, it will no longer turn, and it is better not to hold the key in such situations. So just like that, you can actually build a motor control system, but what will be different is when we want to control the robot by, for example, we want to control the sensors. So we code in such a way that, for example, this Arduino, which is the central circuit, makes decisions based on the sensors, and then there will be no more generalities. Well, based on the sensors, it decides, for example, how to turn the motor in which direction. These are the main things that we will now work on in more advanced rounds and driving sessions. So you see, now I put the speed on the lowest speed and turn it in reverse again. Look at the car. It's going up with a very small face. You can see that it has a very small face, and even its face is coming down with a counter trend here. Now, let's do it the other way around again, with the same face again. It rotates in the opposite direction. Now I'll set it to normal, meaning I'll change it from low to normal and turn it all back on. You'll see that it's a bit of a middle ground between the series and the count. I can easily control a motor. Now I can even make these generalities into a handle and control a motor in different directions and make a controlled robot, which of course we will make in the future, and you will see. Well, just as easily, you can actually control a servo motor in the way you learned. And it is very easy. As mentioned, we have provided you with all the files of this session, which you can download from the video description link below. I hope that this session was useful for you and that you have learned a lot of information and that you can easily build your own robot with the necessary preparation and skill. First, in this way, you will build different circuits of the robot. Then you will learn how to build and make more advanced robots. In the future sessions, when we are going to build an ARM robot, we will use the same SCNV servo motor that you saw here. In the next session, we are going to go into controlling DC motors and calculating the speed of DC motors. Here, you actually saw the angle of motion of the servo motor, and we were able to set its speed in 3 stages. DC meters are different, and the speed of DC meters is the same meter that the robot is supposed to move like a car. It is also important to know, for example, what speed its meter can go at. We will deal with them a lot on this account, which is the destination for the next sessions. So, God bless you until the next session.